Hi everyone, this is Jenna Sargent, social media and online editor at SD Times. We're going to get started in just a couple of minutes, but before then, we've got a quick poll that you can answer as you're entering the webinar. We'll leave that up for a few more minutes if you all want to take a moment to answer it. Okay, we're going to go ahead and get started. Welcome to today's webinar, How Mobile Game Cheats Unlock Mobile App Security Lessons. I'm Jenna Sargent, social media and online editor at SD Times. Before we get started, I have a couple of quick housekeeping announcements. First, this webinar will be recorded and available on demand through the sdtimes.com website about 24 hours after the event. Second, if at any time you have questions about or during the presentation, you may submit them using the control panel's question tab. In this webinar, Jan Saradinsky, mobile security researcher and pen tester at GuardSquare will highlight the common ways mobile apps are compromised by exploring the underlying techniques used to hack and cheat popular mobile games. Now, to get things started, I'll throw it over to you, Jan.
Yep, thank you for a great introduction. So, my name is Jan Saradinsky, and I will talk about cheating in mobile games and how the same cheats can be reused in regular apps. So let's start. I will show you a number of techniques that attackers use, including the techniques that actually allow to walk through walls. And here, let's start from a short demo. Here you can see Among Us. That was quite a popular game in 2020. And here we are that player in the center, the red one, and obviously we can't go through walls in Among Us. However, I'll show you how easy it is actually to walk through walls. The only thing we need to do is to just turn into a ghost, and once we are a ghost, we can just go to the left, and once we are on the left side of the wall, we can just turn back into being a human, and everything in just online multiplayer mode. And apart from that one, I will show you a number of different techniques, like for example, how attackers bypass payments and Touch ID screens. I will also talk about how people download paid apps for free, so how they just bypass the whole payment process. And then I will cover how attackers just unlock premium features in your apps and games. And I will also cover how attackers tamper the memory directly in apps, for example, to get premium currency like diamonds in games. And later on, I will provide you 4 simple guidelines how to protect your app against it. I'll talk about environment integrity, application integrity, code integrity, and obfuscation. So I will start from environment integrity. So let's start from another demo here. I'll show it to you based on Tamagotchi. That was quite a popular app in 2020 as well. I believe it was even in top 15 in Apple App Store and on Google Play. And here we have diamonds. And right now we have 1,478 diamonds. And that currency is quite premium because normally we need to pay for it. So I'll just prove it to you that we need to pay for it. Here you can see we just need to pay for it with real currency. And well, obviously attackers don't need to pay for it. And it's actually quite easy. So right now we opened another app that is a memory scanner. In there, we just enabled Tamagotchi. So we just enabled a memory scanner for Tamagotchi. We opened the application again. And once we open the app, we can see that that red gear button appeared here. And that one is actually an overlay for the memory scanner. And once we tap on it, we can just scan for the whole memory, and we will just scan for the number of diamonds that we have right now. So let's tap on that button. We just choose search, search, and then we type the number of diamonds that we have, and we will scan the whole memory for any variables that have that value. And you can see that there are a lot of variables with that value. So we just need to filter out those variables and make sure which value refers to number of diamonds. So let's buy something for 1 diamond, and we can buy sushi for 1 diamond. So our number of diamonds decreased by 1. And let's filter it out. And right now you can see that only the first variable had that value. So we just tap on it. We can type any number we want. And right now we just changed that, that value in the memory. So the value is already changed. However, the graphic of the game hasn't been refreshed yet. So let's close the app and let's open it again. And once it's open, you will see that the number of diamonds changed to the number of our choice. Yeah, here you are. So right now it's 7777, and we didn't have to pay for it, and we didn't have to know any hacking skills. We just need to open an app and just scan the memory and do everything there. So it was quite easy to achieve that one. So before I show you how it works, I will show you one more example that works based on quite similar idea. And here we have another app, and in here we have a lot of ads. Like there is one ad on the top left corner, then on the bottom. And if we tap on that crossed ads button, we can just remove those ads. But if we tap on it, well, we will be asked to pay for it. And obviously hackers don't pay for that kind of stuff. So we can attach Frida to our app, and we can invoke any function then. So we will just invoke onTransactionSucceed. And that is a function that would be invoked after the successful payment. So if we just use the touch ID here and we paid for it, that function onTransactionSucceed would be invoked. But right now we just attach to the app, and we will just imitate, we'll just invoke artificially that function. So let's invoke it. Now let's tap on cancel. Well, the app will crash because probably something went wrong in the memory, but we don't care about it because we triggered right functions to remove ads anyway. So as you can see right now, there is no ad over here and nothing on the bottom, and we can play normally in that game. So quite easy. And what's actually worth mentioning here is that the same technique works for Touch ID screen. And well, right now I'm showing you the demo on iOS, but those all techniques work on Android too, so it doesn't really matter which platform you use. So protecting against those kind of attacks is called, well, I was actually able to hack those apps because the system was compromised, and protecting against a compromised environment is called environment integrity. And in here, we just check if the device is jailbroken, rooted, or if an app is running inside a simulator, or maybe the whole system is running inside a simulator. And it also has a lot of possible threats, like we can invoke any function, as we just showed it to you, or well, someone can scan for variables inside the memory. Or well, if you have a jailbroken or rooted phone, we can easily just install a tool like the memory scanner that we used to easily modify the memory directly. So it's actually quite easy to use it. And a lot of companies were victims of that kind of attacks. And well, it is actually quite commonly used for invoking functions that lead you to the top of the leaderboard ranking system. So many cases like that already happened. Right now, I'll show you the do-it-yourself section for environment integrity. So you can check if the system is compromised in many ways. For example, on iOS and on Android, you can just check for some files on the file system like binbash or sbinsu on Android. Another way is to check what applications are installed. And on iOS, you can just look up for Cydia. You can just check if Cydia URL is registered inside the system. And if it is, then you know that, well, Cydia is installed, so the system must be jailbroken. On Android, you can use the package manager to list all of the packages in your system. And if you find the Magisk, you know that the system is rooted. Another way, a bit more advanced one, is process properties. So when you, well, for example, on iOS, when you download an app from App Store, the app cannot modify itself, and no app can modify our app either. So if you have a jailbroken device, the jailbreak tool actually removes some constraints from the kernel, and those constraints are actually the flags of the process. And if the process doesn't have a cskill and chhard flags, then the process can modify itself, and also other processes can modify our process. But luckily, we can ask the system to show us our flags for our process, and we can just check if there is cskill and chhard flag. And well, cskill means that an app would be killed when someone patched it in the runtime. And on Android, we can just check if the system-wide debugging is enabled. And if it is enabled, then it means that someone just tries to debug our app. Another way that is mostly popular on Android for emulator detection, we can check the name of the device we are running on right now, and we can just check if it contains an emulator string. But also we can just check some unsupported machine instructions. So on Android, we can also use NDK, and NDK has just native instruction set there. But a lot of emulators don't implement all the instructions. So the app would just behave differently than normal. So we can use some strange, very rare machine instructions and check if the behavior differs. For more ideas, I recommend going to OWASP MSTG. You can find there more about environment integrity. But right now, we are going to the second section, the application integrity, and it is about installing a paid app for free. So there are more app stores and Google Play stores than original. So for example, we have here App Store, but there is an alternative store which is called iOS Got Apps. And in there, we just don't need to pay for apps. So you can see that in App Store, we normally would have to pay €8 for a Minecraft. But if we download it from iOS Got Apps, we can just get it for free. And it's actually quite easy how to do it. So firstly, an attacker would just download a paid app and then install it on a device. And once the app is installed on a device, we can just download the IPA or APK file from the device to our computer. And well, once we have the APK file or IPA, we can just share it with anyone. We can share it with friends or even distribute it online and just allow everyone to download it for free. So that one is actually quite easy to do. Just pay once and then redistribute it. But also, when someone has an APK or IPA file, they can edit files inside. So for example, here you can see a Bomberman game, and the map is defined by a JSON file. So you can see that the river is actually number 174 inside the JSON file. And well, we can just change those numbers in any number, or in whatever we actually want here. So we can create a river out of JSON values here. So, well, we can leverage it in many different ways. For example, if there is, a hard monster inside the game that we cannot, win with, then we can just remove it from the map just by removing a value inside the JSON file. So it's quite easy. And how it's done? Well, so we firstly install that app, then we download it. And once we have it on our system, we just modify it. We just need to find the relevant map that we want to modify. In our case, that was in a map file world folder and then one of those files. But what's important here, we don't need, well, the attacker isn't constrained to modifying only the JSON files. They can also add new dynamic library. And if they can inject a new dynamic library, they can just inject new functionality. Like it's just a whole new logic that is injected inside our app. So they can just change the rules of the game or actually anything. So protecting against those is called application integrity. And it's about verifying if the user is running the correct version of the app, if he's running our version of the app, and if the resources haven't been changed, and well, if the app comes from App Store or Google Play. So there are a lot of possible threats coming from it. So our app can be redistributed for free. There could be built-in cheats, but also modified assets or even more assets. Someone can just inject a new stuff. Like for example, in Duolingo or Mimo, well, those are just tutorial apps, kind of. And well, people are just injecting new courses there and just make it available for everyone for free. Just by inserting new, well, I'm not sure if it's a JSON file, but just new assets inside the IPA or APK. Well, also someone can inject a malware, which is quite important too. But also someone can repackage our app in a way that it allows to attach a debugger. And once they can attach a debugger, they can invoke any function or just scan the memory and overwrite things. So there is a common belief that you need to have a jailbroken or rooted device to hack apps or games, which is totally not true. You just need to repackage your app in a way that allows you to attach a debugger. Once you can attach it, you can, well, imitate the whole compromised environment. So invoke functions or scan the memory. Well, and a lot of apps were actually victim of becoming free on third-party stores like Sleep Cycle or Camera Plus 2. They were paid apps firstly, but now they are available for free, unfortunately, on those alternative stores. So here are a couple of ideas how you can protect your app so your app won't get compromised in that way. So on iOS and on Android, you can check in the runtime if your package name or the signature hasn't changed. So if an attacker adds a new asset or your dynamic library, they just need to repackage the app. They just need to sign it with a new certificate and create a new package name for it, because otherwise Apple, for example, won't let you assign the app. So you can check for the package name or for signature. And those two things work on iOS and on Android. Then you can also check the files in your app package. So, well, as you saw before, we just modified a JSON file. So you can just check a JSON file in the runtime and be sure that no one tampered your map. An important thing here is that we should check if our app is debuggable or is debugged even right now, because if it's debugged or can be debugged, then well, someone can imitate the compromised environment, and as I mentioned before. So we can check for it in many different ways. We can just use ptrace on Android, and if you use ptrace, then the app will just crash if it's debugged right now. But also we can check the parent PID. So normally an app is opened from the main menu, and that main menu has PID equals to 1. So if our parent PID is different than 1, then we can be sure that the app was loaded from a different app, which is, well, in most cases, a debugger. Also, we can check for process flags, and here we can just check for CS debugged flag. On Android, we can just look up the manifest XML file where we should check the debuggable flag if it's set to true. If it's true, that it means that someone can just debug our app. Also, we can check on Android if the application is being debugged right now, and that one we can do with debug is debugger connected. For more ideas, I recommend going to OWASP MSTG. Again, there are a couple of more ideas how to fight with repackaging of apps. So the third section, unlocking premium content. So a lot of apps have been patched in a way that there is, for example, unlimited number of coins or gems or mints. Like in Plants vs. Zombies, we can see that someone patched enough that we have unlimited number of coins. Well, the same for Bloons, but here we just have unlimited number of money, or for Duolingo, where we just have, unlocked premium account. And well, it's actually quite easy to download those apps. We just need to go to an alternative store and download them for free, firstly for free, and then with those unlocked hacked features. And in the case of Duolingo, well, it is, I'm not sure if I remember it correctly, but I believe that you can retake one exam 5 times maximum, but with that patch, you can retake the exam how many times you really want. So here I want to show you how actually that kind of patching is done. So on the left side, we can see the check license code, and that's the developer's perspective. We have just a function, check license. In here, we just pass a string, which is, well, our license. And then we just ask the server to validate it for us. And if it's validated correctly, we just set is valid to true, and then we just return is valid. And from an attacker's perspective, it looks a bit differently. So the hacker doesn't see Swift code or Objective-C or Java, Kotlin, or any high-level language. The hacker mostly works on assembly or Smalley in case of Android. So here you can see how the attacker would see that function. And that's a graph. And on a graph, well, so wherever graph has a branch, like here, that means that there is an if statement, for example. So it is actually super easy to spot where the if statement is. Just before that if statement, we can see what function was invoked to check the condition. So in that case, we can see that there is validate license on server invoked. And then we use tpz instruction to check if the return value from it is equal to true. And if it's true, then we take the left branch and we assign true, which is actually 1 in assembly word. We assign it to isValid variable. And then we just go back to our control flow and we return from the function. So from an attacker's perspective, we just need to change the TPZ, which is our if statement condition, into the reverse one. So, well, basically, we can just change that instruction from TPZ into TBNZ. So TBNZ stands for check if return value is 0, and then TBNZ check if the return value is not 0. Well, once we patch it, we just produce a new binary, we repackage the app, and from that time onward, we'll always return true from the check license function. So protecting against that kind of attack is called code integrity, and it is about verifying if the execution code is still identical to what the developer wrote. And well, we just check if the machine code or Java instructions aren't changed. And it also has a lot of possible threats. So someone can unlock premium content. And well, as I mentioned before, someone just took Duolingo app and just, well, firstly, made it premium for anyone and then unlocked all the premium courses. But well, so for Typorama, for example, in there, you actually need to pay for any feature. So, well, it basically allows you to add filters to images, but you need to pay for each filter. So an attacker just patched the app in a way that it has all of those filters available from the very beginning. But there are also other threats like removing ads. So ads are often the only one revenue for many games and apps. So if an attacker can remove ads, then well, users, then they can, well, then the attacker can just distribute the app to others. And then, well, people just prefer to use apps without ads. The same is about games. So, well, another thing, inside games, we can have unlimited currency, but also what is quite important, we can bypass the whole authorization screens. And right now we are going into do-it-yourself section. And firstly, we can calculate the checksum of our sensitive code. So let's say that the check license was our sensitive function. And here we can see all of the assembly instructions we had there. And well, inside the memory, we cannot see those assembly instructions as strings, obviously. Each assembly instruction is represented as an opcode, and opcode is just a sequence of bytes, and one instruction is equal to just 4 bytes on ARM architecture. So basically, to checksum our sensitive code, we can just check those opcodes inside our function. So we just need to check the values under the addresses where we have our function in the memory. So, well, basically, we just need to check those opcodes, create a hash out of it, and at the end, you can check that hash. So here on the right, you can see a short snippet of code, how it could look like. Firstly, we have a for loop. We start from the first address of the function. We end the loop at the final address of the function. We increment by 4 because the size of the instruction is 4 on ARM architecture. And yeah, here we just dereference the pointer, well, the value under the pointer. We take the opcode. Later on, we just create a hash out of it, and hash can be anything. We can just add, opcodes to each other, and then at the end, check if that value matches the value that we had during the compilation time. So after the compilation, we should just save our hash magic number somewhere, and during the runtime, we can verify if that hash hasn't changed. So we can also verify the whole binary, or we can check the whole classes.txt on Android. Another important thing is swizzled methods. So a swizzled method is a method for which the function pointer was changed. So if you try to invoke that function, another function will be invoked instead. So, well, more about the topic is written in a blog from my colleague from GarSquare. So I recommend you visiting the blog and reading about it more. You can find their ideas how to fix the swizzled methods on iOS and on Android too. Okay, so now I will tell you how we were actually able to walk through walls in Among Us. So everything starts from symbol obfuscation. And symbols are actually the names of classes, functions, variables inside our app. So we were actually able to recover those symbols. And in case of Among Us, we recovered a class player control, which had die method, revive, set skin, and murder player. So we came up with a plan for the attack to find a relevant function that we could use to walk through wall and then invoke that function. And in case of the compromised environment, we can just attach with Frida and invoke any function that we want. Well, if the app doesn't feature an application integrity, then we can attach a debugger to it, and well, we can imitate the whole compromised environment and attach any app invoke any function that we really want. Later on, if the app doesn't check for the code integrity, we can just patch the app and make it invoke certain functions in the runtime. So here we tried to invoke die function, and then, well, we actually turned into a ghost. So we tried to walk through the wall. We were actually able to walk through the wall, and once we are on the other side, we just invoked revive, and well, the whole validation took place at the client side. So no server actually checked it. So once we revived, the server even didn't know that we were dead for a couple of seconds there. And we used the same techniques for the second demo in this presentation. So you remember bypassing payments when we actually invoked on transaction succeed. So we dumped symbols from the app. We just saw that function on transaction succeed, and then we thought, oh well, maybe that function is invoked after the transaction succeeds. So we tried it out, and it worked. It just removed all of the ads inside the game. And here you can ask yourself, how many meaningful names do you have in your app? And what's also quite important in that place is that if you have a game written in Unity, then it leaves a lot of metadata inside APK or ITA, which is even a way easier to dump, because then a lot of symbols are really in the clear text. Like, for example, Among Us is written in Unity, and we were able to even extract the types like enums. So make sure to obfuscate your app, and I'll show you in a second how to do it. But firstly, obfuscation is not about renaming the variables or method or classes, but it's also about encrypting strings, tokens, and other API endpoints. So let's say that we have a token inside our app, and we use the token to communicate with a third-party server. for example, with a map. And then if an attacker can get our token and they can spoof the communication with that third-party map, they can spoof activity of our user. And in that case, we will probably get quite low reputation on App Store reviews or on Google Store reviews. The same is with APIs. So if we don't encrypt our API endpoints, then someone can just target our backend endpoints. So they can just extract all of the URLs and then use automated tool to just try to hack all of those endpoints without even targeting the client. But if we encrypt those strings and you have strong SSL ping, it's hard to really extract those endpoints from there. Another thing is control flow. So, well, if you have an app that, let's say, adds a filter, it applies a filter to an image, and there is a function which takes a PNG file as an argument, and then it applies that filter to it and returns the fixed image. An attacker could just extract that function from the app or from the game and use it in his own app or game. However, if we make the control flow super hard to understand or even dependent on other things inside our app, then the attacker won't be able to to just extract it and reuse it. Also, an important thing is to encrypt your assets. So let's say that you want to surprise your customers with a new assets for holidays, and you don't really want anyone to reveal it before you do during the first day of the holidays. So you should encrypt it, because if you don't, then an attacker can, for example, decrypt it on his own and create a version of an app that has those assets available, and we can just upload that app into a third-party store. So there are a lot of companies that, which primary focus is to reverse engineer apps and discover their secret API, and then they implement clients for them. So if we want to keep our IP for ourselves, we should remember about obfuscation. So a couple of ideas how to obfuscate your app. I will show it to you here, but firstly, developers should write the clean code, but the obfuscation is about the opposite. So it's a bit counterintuitive, because if you want to obfuscate the code, then we would have to write really complex names for our class or a method or a variable. So it's a bit counterproductive, we could say. That's why I believe that we should use compilation time solution, because then we just don't need to care about writing an ugly code. So for simple obfuscation, I recommend using a free tool from GuardSquare, which is called ProGuard. You can use it for free, and it will just remove all of the symbols from your binary. When it comes to control flow, I don't really know any free tool that you could use. However, if you really want to make your code harder to understand for an attacker, you can just use a lot of different control flow statements. Like you can use a while loop that would execute only once, and inside here, you could put a lot of switch statements and cases. And you can put there a lot of predicates like time, because we always know that the time is just bigger than 0, but that time must be executed in the runtime to be compared, so it won't be optimized by the compiler. For string encryption and resources, you can use XOR. Well, obviously, the more complex math you use, the better for you, and it's just harder for an attacker to understand. but if the attacker can't see everything in the clear text inside the APK or IPA, it's already a big win for you. So to sum it up, we covered 4 different components, and each of those components matter. So, well, I'll show you why they actually matter. If we don't have environment integrity implemented in our app, then someone can just bypass the application integrity. Because if we have, let's say, we just check for the signature and someone repackages our app, then the attacker don't need to resign the app, because on a jailbroken device or on a rooted device, the system doesn't check for the signature. So, well, if we check for the signature, the attacker doesn't need to even resign it, because, well, he's just using the jailbroken system. So we need to implement all of it to get it to work properly. Another case is if we don't have application integrity, then someone can repackage our app in a way that it allows to attach a debugger. Once we have a debugger, we can imitate the compromised environment, so we can just invoke any function or scan the memory or other ideas. Well, then if we don't have code integrity, someone can just patch our code. So, well, we already covered how patching the code works, and we already know a lot of different ways to protect the environment integrity. Like we can check for some files or Cydia if they are installed. We can create an if statement that checks for it. But if an attacker can just patch our app in a way that the if statement is reversed, then, well, then our protection won't work. So we should also make sure to checksum our code to make sure that nothing is overwritten there. And then we should also remember about obfuscation, because if we don't obfuscate the app, it's just easier to find relevant symbols inside the app, like functions or like function names, variable names, or class names. So, well, here you should remember that we really need to get all of those components to make our app secure. You should have environment integrity, application integrity, and code integrity, and obfuscate it all just to be sure that no one understands our code. And before you go and actually implement some new ideas, some new protections in your app, you should remember about a couple of things. Firstly, update your protection code regularly, because if you don't, you will just give enough time for an attacker to understand your code. So if you update your code, let's say at every release, then the attacker just doesn't, well, then it doesn't matter for him, because you just changed your code base completely from his point of view. So if you change all of your protections at once, then an attacker needs to actually start from scratch. So it's quite good to use build time solutions, because then you can just change the whole code at once during the build time. Also, you should make sure that your protections will work on new iOS and Android versions, because right now your protection may work, but, well, if there is a new version, let's say iOS 15, and then your protection doesn't work, then an attacker can just leverage it and try to hack your app. But what's even worse, there could be false positives on new versions of OS. So if there is a new false positive, then your check triggers, and, well, it depends what you will do when your check triggers. But in most cases, it mostly crashes the app. So make sure to check new iOS and Android versions, and make sure that there are no false positives. So check out beta versions before the whole new version is released, and check if your protection works. Okay, that would be it. Thank you for your attention. And yeah, let's go to the Q&A section.
Yeah, if anyone has any questions, feel free to drop them in the questions tab in the control panel. We're going to get started with some of the ones I've seen already. So one question is, what if my app gets uploaded to a third-party store? How can I protect it then?
So, well, it really depends on the app. Well, obviously, we can write an official complaint to the third-party store and say that, hey, please remove my app from the third-party store. But I don't believe that could work. Well, probably your app will just remain hacked, and you just need to create a new version and make sure that now it's secure. However, you can also, well, totally change your backend endpoints, but that would be quite time consuming, and also an attacker could cache the backend, so it wouldn't matter for him. He'll just cache the whole server side and let users play your game or app. So make sure to implement those new features, those new protection features in your app, and yeah, just in your new version.
Would the bypassing payments method not be easily defeated by just inlining these kinds of functions?
So a lot of APIs takes as an argument the function pointer to the function that should be invoked when certain thing is done. So in that case, we can't really use inlining because we just need to give the function pointer to the function that needs to be invoked. Like on transaction succeed, it couldn't be inlined. It has to be the whole symbol. So inlining is, I believe, not an option in that case.
Another question is, I know there are open source obfuscators and RASP frameworks. Would you recommend using those?
You mean open source frameworks for protections? All right. So for iOS, I know iOS Secure Suite, and that one is open source. For sure, it's good to use that one because, well, firstly, it's open source. The only thing that I don't like about it is, well, firstly, because it's open source, so a hacker would know what protections there are, and, well, he would immediately spot that it's iOS Secure Suite, and they could just create a Frida script or other script in front and just bypass all of the protections at once. So in my view, you should take ideas from open source projects and implement it in your app. Don't take the whole ready frameworks because there are probably a lot of tools that can break them.
Okay. Does the getting free diamonds memory modification technique really work in a lot of cases? I would think that it causes memory issues, making the app crash.
So when I was doing the research, I checked like about 20, 30 top games in iOS App Store and in Android Play Store. And I remember that at least 7 were vulnerable to that one, which is quite a lot. And those apps were like top 10 apps. So they should be, well, the most secure. So yes, that works and it's out there. Well, if it crashes, then I would say try to filter out better. Like we bought sushi for 1 diamond in Tamagotchi case, and try to filter it out. If it doesn't work, then probably there is a backend side validation which can be bypassed in many ways. But I believe it's a topic for another webinar.
Awesome. I'm not seeing any other questions in the webinar, so we're going to wrap up here. Thank you for a great presentation. Again, that was Jan Saradinsky, mobile security researcher and pen tester at GuardSquare. I would also like to thank GuardSquare for sponsoring today's webinar, as well as the attendees for joining us.
Thank you.